Hello everyone. In this video, we are going to learn non-linear analysis. This is the next step to the response spectrum and time history. See, after giving a time history, non-linear analysis will be done. Okay. See, linear analysis is unlike to non-linear analysis. Okay, there are types of nonlinear analysis, that is static nonlinear analysis, then dynamic nonlinear analysis. There is another type is FNA, this is fast nonlinear analysis. The next is nonlinear analysis with direct integration. Okay, incremental analysis also there. Okay, then what is the application of uh, nonlinear analysis? It is analyze complex structures. Okay, then it will provide advanced design checks. Then next is it will having a computational intensity, okay, as compared to linear analysis. Okay, then modeling complexity. Okay, so it will analyze the complex model. Okay, see, choosing between the linear and nonlinear analysis depends on the specific characteristics of the structure and the location, the expected loading condition, and the desired level of accuracy. Linear analysis is simpler and faster, but may not capture complex behavior accurately as compared to non-linear analysis. Okay, the non-linear analysis, while more computationally intensive, provide a more realistic assessment of structural response under non-linear condition, essential for critical design scenarios. For example, having a fifth zone in earthquake. Okay, then the both method complements each other in structural engineering practice, such as serving its purpose in different stages of analysis in design. Okay, I'm going to show you directly in software. Okay, going to make one new software. See, in non-linear analysis, I'm going to give only normal one story building because it will take too much time for high rise building. Okay, choosing all the things. Okay, story 3 by 3. Okay, four numbers. I'm going to make this 4 3 or 4. Okay, in x is going to make 4 and make this 3. Okay, now here the distance is okay, but number of stories I'm going to give it's only 2. And okay, okay, define quickly all the things, material properties and whatever. Okay, here steel is sufficient. Then going to define concrete, it's M20. And rebar. So today we are going to define for non-linear and linear non-linear and response spectrum. So we are going to add fe 500 also and fe 250 also. Okay, then define section. So as you know in your higher studies, the dimensions of the section is have to be greater as compared to normal. So concrete column I'm going to give it's a minimum 500. Okay, the depth is 500 and width is 450. Okay, or otherwise it is 400. Then define as column and longitudinal bar is HYSD 500. Okay, all things are same. Okay, then okay, then add a new column as sorry beam as a Okay, beam as M20. Okay, column I have mentioned is to M30 and beam is M20. Okay, the beam is now going to define is 400 by 350 and beam. Okay, for beam I'm going to give stirrups as 250 and fe 250 and bottom bars clear cover is 25. Okay, here you can change what if you want. Okay, this is a designed section. Okay, as per manual calculation, so I'm going to put this also. If you have another types of section size, you can put it and analyze as per your requirement. Okay, here I'm going to give is 300. Okay, click OK, then define slab section. Okay, I'm going to modify only this with the M20, 150 mm. Okay, then okay, then define first thing is to define load. Now I'm going to define only dead load, live load. Okay, and another one is earthquake load only. Okay, then I'm going to modify this for x direction eccentric and x direction, and for y also eccentric and normal. Okay, then okay, then define. Okay, here you can also define mass source. Okay, mass source is default mass source is MASRC. Okay, you can add it whatever you want. Okay, then add specify load pattern, you can add. Okay, now if I add here, so I cannot add in load pattern, so I'm not going to add here. Now go in load combination, default load frame. Okay, and define function, that is now I'm going to define its time history. Okay, for from file add a new. Okay, I'm going to browse the file for knowing how to add time history. You can check my previous video, there I have mentioned uh, how to add this time history from file. Okay, the file is taken from postcos.in. Okay, there is a response spectrum locations or the area where uh, Richter scale and all the things as captured. It is published by India government. Okay, I am going to check just first thing. Okay, just a second, I am going to search it first. Okay, I got this th and file. Okay, this is the original for graph, function graph. Okay, the pixel charts per line in skip. Okay, 0 I have put. Okay, you can see the file here. This is the values I got from after downloading. Okay, now you can make it time function. Okay, and it is data from file user. Okay, or you can make it like this. Okay, if you want fixed format like this, the character is 10, format type you can change. Okay, I have make fixed format on okay, th1, then click ok. Then I am going to define load cases. Now I am going to define its add new. Now here is already linear, so I am going to make this non-linear. Okay, the before making non-linear. Okay, here is also option is non-linear, or another option is time history and non-linear. Okay, here you can make like this, otherwise you can make from here. Okay, non-linear, and the mass source I am going to define is mrsrc 1. Okay, where we have already defined. Okay, this load pattern I'm going to make acceleration ux, then acceleration for uy, and acceleration for uz. Okay, for model also you can make it model load. Okay, then model case is here. Then geometric nonlinearity option is p delta and p delta plus large displacement. Okay, I am going to make is none. Then load application is full. Okay, here is full displacement or quasi, so I am going to make it full. I want all full report. Click ok. Okay, I have add non-linear. So for this also modify th and non-linear. Here you can see they change the acceleration or load pattern eqx function is th add. Okay, for load pattern y and th. Okay, so all the things I have make it as it is and okay. Okay, time history for y also. Okay, so here, okay, the first thing is non-linear and a model. This FNA means faster non-linear. The next is direct integration. It will take too much time, so for that video will be longer, so that I am going to use fast non-linear. Okay, then delete this first, and the another thing is to modify, and for this I am going to delete for x direction only I want. Okay, similarly for here y direction I only want. Okay, then click okay. Then all the things we have already defined, it's so go directly for draw. Make joint as fast, and as fixed, and click OK. You come to select, sorry, select column, define load, and first calculate the load for column self-it is 0.5 into 0.4 into 20. Okay, done. Next, select beam, calculate 0.4 into 0.3 into 25, 3. Select floor, then assign floor shell load, uniform, okay, and then select both column beam, select assign rim load, distributed lie load, and then as it is, I'm going to make it lie load is 3. Okay, then select again for earthquake X for X direction, and always remember the earthquake load is 1/2 to the live load. Apply, then again select for Y direction, change the direction and 1/2 to the live load and apply. Okay, similarly for floor, select assign shell load, uniform load, live load is 3, apply, then select earthquake load is 1.5 for X direction, apply, then select, then apply, and okay, all things we have assigned. Then go for, see here you can analyze, check model before it, analysis in process, model has been checked, no warning message were generated, so we can go for analysis. Okay, first check set load cases. Okay, I'm going to run now, or you can make from run analysis and save it first. Model is saved and analysis is in process. The analysis is going on. Okay, so we can check the warnings, error or no error or warning message found between the current intersection point and the end of the log. Okay, so no warning and no messages. So okay, click done, close it. Okay, then we are going to check loads. Okay, for X direction, see this is the load cases reactions at the base for live also. Okay, but first thing is for non-linear we are going to learn. For non-linear, Okay, you can see the results are available. Okay, then similarly for deflection for non-linear, apply. Okay, here you can see the deflection is 0.06 mm, the maximum, and the minus is 0.004. Okay, then it is, we can say it is safe. Okay, for axial also we can check. This is the torsion and axial force which is available. And then I'm going to check shear. Okay, this is moment and shear. Okay, for shear is beam, the deflection, moment, and the shear is 0.86. Okay, then done. Okay, we have only check for non-linear. Okay, now we are going to check shell stresses for non-linear. Okay, you can see shell stresses for non-linear resultants or say shell stresses, the visible face, top face, bottom face, maximum. I'm going to make maximum and apply. Okay, this is maximum at pot twin. You can change your cursor. Here you can see. Okay, similarly maximum here, apply. Okay, like this. Okay, then visible face, or you can change for absolute maximum. Okay, like this you can check shell stresses. Okay, then for deflection for non-linear, here you can see hinges state consider colored dots are for B, C, D and E point. Okay, and apply. Like this the animation will show like. Like this for our non. Hope you guys understood. Okay, till here you can see plot function. Here is plot function for your base tube time. Okay, then you can see performance check. Okay, you can add whatever dg1 set. Okay, eqx number of steps you can define or not for x and for non-linear. Okay, the maximum all the things. Okay, okay, I'm going to apply and okay. Okay, like this the results seen less than 0. Performance check is then story response plot. This is story response plot, response spectrum curve like this. Okay, then display. Okay, plot function we have seen virtual energy work method for dead load. No, we are going to check forces and displacement for non-linear. Here you can see. Sorry. Close. Then in display you can see table. See, I'm going to choose only structural output. Apply. Load case type is only only non-linear. Here you can see maximum and minimum, apex and the base reaction. Okay, the moments and the base reactions are fx and fy direction. Okay, diagram forces. Okay, we are going to check story forces. This for non-linear. See, non-linear statics. Then maximum the location top and bottom, and shear force, a torsion and movement. Okay, you can check here. Okay, total energy. Okay, all things you can check here. Then element non-linear energy by group. Okay, group is all, you can check maximum moment or things. Okay, hope you guys understood how to do non-linear analysis. Thank you.